Sandhan. All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.
Hello friends, myself Dr. SANDHAN-AGIC and I am from Universal College of Engineering and Technology. Today I am going to discuss about the radioactivity. From the word radioactivity, there are so many questions in your mind. What is the meaning of radioactivity? How the radioactivity will occur? Now before going to in the radioactivity, we should know about what is the meaning of radioactive, what are the radioactive elements, and why the radioactive decay is occur. So for that reason, we will discuss about the atomic structure and how the elements can be formed, how the alpha, beta and gamma rays are emitted from the radioactive elements, and the basic concepts of atoms. Then we will see how the radioactivity is discovered. Let us see. This is the outline of my today's talk. First of all, I will discuss about the introduction and the history of atom. Then, how the atom and molecule, or you can say the atomic structure, can be made by the chemical formula. Then we will discuss about the history of radioactivity. After that, we will discuss about the radioactive decay, which are the alpha, beta and gamma decay. Then, the half-life time and the disintegration constant of the radioactive elements. The nuclear fission and nuclear fission, why this kind of phenomena are occur, and what is the importance of fission and fusion, how they are connected to the radioactive activity. And at last, the last topic is the effects of radioactivity on our human body and what are the advantages as well as the disadvantages of the radioactivity. Okay, so let us start with the history of the atom. What is the history? What the people were thought around 100 or 200 years ago? What are the concept in their mind? In 1909, John Dalton was thought that atoms and molecules are a sphere. He said that atom is a solid sphere. You cannot disintegrate the atom or molecule. This was the concept around in 1909. That's why its model's name is solid sphere model. After that, another scientist has given his concept. See, it was the concept of J.J. Thomson. What he has suggested, he has thought that the nuclear means the protons or the neutrons, whatever the charge of the nucleus, they are spread throughout the atom. It was not the concept of the center of the nucleus, which we know now, which we aware right now. And the electrons are spread throughout the atoms. You can see in the figure, the atoms positive charge as well as negative charge are mixed. This was the concept of J.J. Thomson. That's why it's called the plum pudding, a sphere of positive charge with negatively charged electrons spread through it. After that, there was a nice experiment was done by the Rutherford scattering experiment. What he has done? He has taken the gold foil, thin gold foil, and the alpha rays are scattered from the thin gold foil, which has a positive charge. What happened? You can see in this figure, there are rays, most of the rays are scattered from the boundaries without any kind of interaction with the center, but the some rays are scattered back, which are from the center of the nucleus. You can see in this figure. When the rays are scattered from the center of the nucleus, center of that atom, it is scattered back to the own region. These are these rays which are coming back because of the center of the nuclei of the thin gold foil. These particles pass through and somewhere deflected backwards, which has a small angle. So by this experiment, he has made the conclusion that atom is made up of a small central nucleus surrounded by electrons orbiting in cells. This was the first concept of the Rutherford. Now After that, there are so many other concepts of Schrödinger, yes, de Broglie and Schrödinger. What he has made the concept? He has said that the center of the atom is made up of the protons and the neutrons. It is called the nucleus, and the electrons are surrounded by the nucleus, which are looking as a cloud. You can see in this figure, the electrons are in the cloudy form. This was the postulate of the Bohr. So quantum mechanical model proposed by the Louis de Broglie and Schrödinger, the electron cloud has been postulated later on. After that, all the discovery of these scientists, the people now understand that there should be some center in the atom or molecule, and that center should that center should have protons or the neutrons, and the electrons should be the surrounded to that protons or the neutrons. This was the understanding is created at that time. So protons carry a positive charge, the neutrons are the electrically neutral. Now why the nucleus contains the protons and neutrons both? If you guess, if only protons are in the nucleus, then it cannot stay in the nucleus because proton has a positive charge. So two protons means two positive charge cannot stay together. That's why the neutrons are also in the nucleus, and that's the reason why the nucleus is bounded by protons and the neutrons. And then whatever the number of protons, that number of electrons are surrounding the nucleus, which has a negative charge. So whole the atom is become neutral because proton carries a positive charge and the electrons carries a negative charge. So this plus or minus will cancel each other and atom will become neutral because neutron has not any kind of charge. It is a neutral part here. So without neutrons, the nucleus would split apart because the positive protons would repel each other. This was the theory. Now we can say we can take the example of hydrogen atom. I think you all know aware that hydrogen has two other isotopes. Hydrogen is a simple atom which has only one proton. Now if you add one more neutron to the hydrogen nucleus, it will form the deuterium. And if you add two more neutrons to the nuclei of the hydrogen, it will form the tritium, which is a radioactive. So why the material will become radioactive? When you add the neutrons in the nuclei, it will form the radioactive material like hydrogen. Here tritium is the radioactive material. Now because of the adding of the neutrons, it will now become unstable. So this is the definition of isotopes, that atoms of the same element which vary in neutron number are called isotopes. Now I will discuss about the atomic structure and its representation, how the atoms can be represented in the chemical formula by using its atomic number as well as mass number. See, the atom consists of two parts. You can see the nucleus, which contains protons as well as neutrons. Protons carry positive charge, neutrons are the neutral particle, and the electrons are surrounding the center of the nucleus, which has a negative charge. So we can say that the smallest part of an element is called atom, and it contains different numbers of protons and neutrons. But whatever the number of protons, it contains the same electrons. So the mass of the atom is entirely because of the protons and neutrons. It has a very much higher weight compared to the electrons. The electron weight is negligible. Now if you want to represent an atom as a chemical symbol, you can do it in this way. See, here Z, A and X, there are three different alphabetical, where A is the mass number, which is equal to number of protons as well as number of neutrons. Whatever the number of protons and neutrons in your chemical element is represented as capital A, whereas the Z is the atomic number, which is equal to number of protons. Now remember that whenever you have to define Z atomic number, you should have answer that Z is equal to number of protons, because when the element is ionized, the electrons can be removed, can be coming out from the atom or molecule, but proton cannot be easily ionized. So whatever the number of protons in your element is called the atomic number, and X is the chemical element, is the element symbol. So this is the sign of all the chemical element which you want to represent. Here A is the number of protons per A plus number of neutrons, Z is the number of protons, and A minus Z is the number of neutrons. So to find out the number of neutrons, subtract A means the mass number minus Z is the atomic number. You will get the number of neutrons in your elements. So number of neutrons is the mass number minus atomic number. Now there are many types of uranium. Suppose we are taking the example of uranium because the elements which has the atomic number more than 82, they are called the radioisotopes. Because in these elements the number of neutrons are more compared to the number of protons. That's why the instability is created in that kind of material. And to become stable, they will emit alpha, beta or gamma, that kind of radiation that we will discuss later on. Let us see how the uranium structure is formed. Uranium has atomic number 92 and its mass number is 235. It means its A is equal to 35, its atomic number Z is equal to 92, the number of protons are 92 and the number of neutrons are 143, which is equal to A minus Z. So you can see here the number of neutrons are very much larger than the number of protons. The second example is uranium-238. For this structure, you can write your A is equal to 38, your atomic number Z is equal to 92. The protons are the same as the number of Z. So Z is equal to 92, so number of protons is the 92, and the number of neutrons are A minus Z, which is equal to 146. So isotope of any particular element contain the same number of protons but the different number of neutrons. This is the conclusion of the slides. Now, most of the isotopes are stable, friends. All the isotopes are not stable. A few isotopes which are natural or some man-made, they are unstable. Now to get the stability, they have to decay the different kind of particles from them, and because of this reason, to get the stability, they are decay the various kind of rays which are called alpha, beta and gamma rays, and this process is called the radioactive decay, and the elements which undergo this process is called the radioisotopes. Now what is the radioactivity? The definition of the radioactivity is as here. The spontaneous emission of radiation by some nuclides is called the radioactivity. These elements spontaneously emit this kind of radioactivity rays or radiation. There was not any kind of external force or not any kind of external energy we have to apply. They spontaneously emit some kind of radiation. Because of this thing, they are called the radioactivity, and the substances are called radioactive substances. Now what is the history of the radioactivity? Friends, see the first and second line. These are the very important, that in 1896 the Henry Becquerel accidentally discovered radioactivity. Now even Henry Becquerel was not known that he is going to find out the radioactivity phenomena. What was happened at that time? He was forgotten some uranium salt on a photographic plate. And when he developed that photographic plate, he has found out that photographic plate was affected by some kind of radiation. And then he thought that why this photographic plate was affected. He had not done any kind of experiment. So he realized that there should be some kind of material, something in this uranium salt by which this photographic plate should be affected. Then he had done some other experiments by the taking of the uranium salt. And then what he had done, he had put some kind of material like paper, wood and glass between the photographic plate and the uranium salt. And he had observed that invisible rays are passing from the paper, wood and glass and affected the photographic plate. Then he had made the conclusion that that kind of some material in the uranium sword which can pass from this glass, wood and paper. It means it has some penetration depth and the material are not the same. There are different kind of materials would be decay from the radioactive element. Then during this time the Madame Curie and her husband has also developed the radium element. Now see, they have also put the interest in these experiments. Then they together done one experiment in which what they had done. See, they had taken the lead material which is a radioactive element, and they had put the photographic plate above some distance of the lead. Now they know that the lead is the radioactive element, but how the radioactive elements was decayed they don't know. So they observe that they have applied some magnetic field to the lead. When the rays are passing from the lead and affected the photographic plate, they had applied the magnetic field. First of all, they had applied the weak magnetic field. By applying the weak magnetic field, they had observed that the spot was found on the direct line as well as the left of the photographic plate. Right, and when they applied the strong magnetic field, they had found out that the spot was appeared on the right hand side of the photographic plate. It means when you applied the magnetic field, this kind of particles are reflected on one other side. One is the right side, one is the left side. It means they should have some kind of charge. They should have some positive charge or negative charge. And during this experiment, they have also observed that some particles are only on the straight line of the path. They are not reflected on right or left side. They are, see in the figure, they are on the straight line, which are the gamma rays. So by this experiment, they have made the conclusion that radioactive